Good morning student, welcome to lecture number 5 module V. Today in this session we will discuss about memory interleaving. In last session we discussed about the FIFO replacement algorithm. By the use of FIFO replacement algorithm, how the block will be replaced in cache memory in an efficient manner that it will create a space for new upcoming main memory blocks. So please look into the videos and try to solve the assignment in a proper ways and post it into my mail id or to my WhatsApp. So come to the topic. In this session we will discuss about memory interleaving. So what do you mean by interleaving? Interleaving is nothing but spreading of memory, or you can say memory interleaving means spreading of memory in your computer system. So what do you mean by spreading? Spreading is nothing but arranging your memory in a different modules so that we can access the memory in parallel natures. Okay, so look into the concept, then you can clear your doubts. So what is memory interleaving saying? Memory interleaving is the technique used to increase the throughput of memory in computer system. The core idea is to split the memory system into independent banks which can answer read-write requests in parallel. Okay, so memory interleaving means dividing your memory into multiple modules so that CPU can access the data parallelly. So look here. Assume that this is your main memory and he has the capacity to store 16 words. So this memory can store 16 words. So to store 16 words, we need to store 16 words. So each cells require how many bits to represent the data? So total 16 words equal to 2 to the 4 means 4 bits is required to represent a cells. That means this number 1 cell address will be 0000, number 2 address will be 0001, number 3 0010, number 4 0011. Similarly, look, in the cell address, first 2 bits are same for 4 times, repeating for 4 times, and the second 2 bits are changing 01, 00, 01, 10, 11. Again, first 2 bits are repeating for 4 times 01, 01, 01, 01. After that 00, 01, 10, 11. Again, first 2 bits 10, it is also repeating same as 4 times 1, 2, 3, 4, and changing value is what? 00, 01, 10, 11. Similarly, next 4 bits are, first 2 bits are repeating 4 times 11, 11, 11, 11, then 00, 01, 10, 11. So this way the data is represented in your, or the words are represented in your single memory modules. So this kind of memory is called what? Contiguous memory allocation in single memory module. This is the memory module which store the data in contiguous manner. So what happened here? Now when CPU want to access the data, he has to access the data in sequential manner, means he will access first 1 data, then 2, then 3, then 4, then 5, then 6, then 7, then 8, like that. After in last he will access the data 16. So if we want to access the data of 15 locations, then we have to complete how many movement? 14 movement. We have to complete 14 movement, then we can access the 15 location data. Are you getting? Already I told you in your pipelining structure. In pipelining there is a pipeline hazard is what? Structural hazard. And why structural hazard is occur? Due to improper management of memory, or you can say if more than one instruction want to access memory at the same time, then it will create what? Structural hazards. So how can we overcome this structural hazard? We can overcome the structural hazard by by the technique of memory interleaving, or you can say dividing the memory into number of modules. So if you divide the memory into number of modules, then we can access the data of the memory of different modules parallelly without sequential manner. In this case we have to access the data in a sequential manner, but if we divide the memory into different modules, then we don't need to wait for the 15 we don't need to wait, or we don't need to move 14s, then we'll get the 15 number data. Okay, so here I divided the this memory block, single memory block, into 4 modules, and each module with 4 words, because there is 16 this memory can hold 16 words. So if you divide this 16 size memory, it will, well, how many module it required? If each module contain 4 words, then dividing the 16 locations, we will get how many modules? 4 modules. Look, this is the 4 modules. This is module 1, this is module 2, this is module 3, this is module 4. So 4 modules, and each modules having how many data? 4 words. It is all 4 words, 4 words, 4 words, 4 words. Total how many words? 16 words. So this is one type of dividing the module, and this is one type of dividing the module, and this is called what? 4-way interleaving memory. This is called what? 4-way interleaving memory. And you can also divide the memory, if you will divide n, then this is called what? N-way interleaving memory. If you will divide into 4 module, then it will call 4-way interleaving memory. So in your memory system, if there is n number of ways, then you can say, or if there is n number of module, then you can say n-way interleaving memory. So here we divided the memory 16-bit single memory module to 4-way interleaving modules memory, and each module having how many words? 4 words. Look here, this data is 4 modules are there. So module 00, module 01, module 10, and module 11, and data are represented in which manner? Horizontal manner. In which manner? Horizontal manner. Look, word 1, word 2, word 3, word 4, then word 5. This is word 1, this is word 2, this is word 3, this is word 4. Then word 5 is here, then word 6 is here, word 7 is here, word 8 is here. 9, 10, 11, 12, 13, 14, 15, 16. So this is which manner? This is horizontal manner. But look here, the data are stored in vertically manner. This is module 00, or you can say module 1, module 2, module 3, module 4, and data are stored in vertically manner. Means what? Word 1, word 2, word 3, word 4, word 5, word 6, word 7, word 8, 9, 10, 11, like this. But here in a horizontal manner, look the difference. Here in the horizontal manner, and here in the vertical manner. This is the difference. So this is called what? Low order memory interleaving, and this is called what? High order memory interleaving. Consecutive words in consecutive module in horizontally. So in this module, data are stored in what? Consecutive words are stored in consecutive module in horizontal manner, and here consecutive words are stored in module in vertically. So consecutive words are stored in a one module in a vertical natures. Okay, so this is called what? Low order memory interleaving, and this is called a high order memory interleaving. So why it is called low order memory interleaving? So look, suppose we want to represent the data 8. What? Suppose we want to represent the data 8. So this data 8 is stored in which memory location? This is what? 0 1 1 1. So it is, this is the location 0 1 1 1. So low order memory interleaving means, come to, this is the last 2 bits. This is what? One. This is called what? This is called what? LSB, least significant bit, or low order. This is called what? Least significant bit or low order. And these 2 bits are called what? What? Most significant bit or high order. Most significant bit or high order. So least significant bit, low order means, so this is used to identify the module. This 2 bits is used to identify the module. So 1 1 means module 1 1. Look, this is module 1 1. So in module 1 1, in which place the value is present? 0 1 place. So look, the 0 1 place, so 0 1 place. So this is the data is 8. Are you getting me? Look, this is the data 8. So this data 8 is stored in memory location which 0 1 1 1. So look, 0 1 1 1. This is called low order memory interleaving. Low order memory interleaving means last two digits will be used to identify the address, or identify the module, and first 2 bit is used to identify the location. So 1 1 means module number 1 1. So look, module 1 1, and which location? 0 1 location. So in 0 1 location the 8 is present. So that this is we are using the last 2 bits, or we are using the LSB bits to identify the module. That's why it is called what? Low order memory interleaving. Are you getting? If we are use last bits for identifying the module, then it is called what? Low order memory interleaving, or you can say lowest significant low order lowest significant interleaving. You can also called lowest significant interleaving models. So this is called what? Low order memory interleaving. And this is called high order interleaving. Means look, suppose if you want to access the data 8, so data 8 address memory location is what? 0 1 1 1, and these 2 bits are called what? High order bits, or you can say most significant bit, and these 2 bits are called what? Low order bit, or you can say LSB, least significant bit. So here first 2 bits are used to identify the module. First 2 bits are used to identify the module. So 0 1, so module 0 1, this is module 0 1, and in which location? 1 1 location. So this is what? 1 1 location. So 0 0 means this is 0 0, and this is 0 1, this is 1 0 1 1. Similarly, this is 0 0, this is 0 1, this is 1 0, and this is 1 1. So most significant is what? 0 1. So module 0 1. In module 0 1, which location? 1 1 location. In 1 1 location 8 is present. Okay, so here we are using high order bits. That's why it is called what? High order memory interleaving. Okay, here we are using most significant bits or high order bits. That's why it is called what? High order memory interleaving. But here we are using low order bits to represent to finding the modules. That's why it is called what? Low order memory interleaving. So this is the difference between two memory representation techniques, or dividing the module techniques. One is low order memory interleaving, another one is high order interleaving. Okay, so look, this is also LSB. You can so here LSB address of modes. In low order memory interleaving we are using LSB address of modules and MSB address of words. Here MSB is used to address of module, and LSB is used to address of words. Look, here LSB is used to find the address of module. So 1 1 means this module, and 0 1 is what? Location of the word. So 0 1 is the location of word, and here 0 1 is used to find the module. So 0 1 is find the address of module. Okay, and 1 1 is what? Find the address of word. So look, 1 1 is the address of words. Get it. So in low order memory interleaving, least significant bits are used to find the address of module, and first 2 significant or high order bits are used to find the address of word. And here most significant bits are used to find the address of module, and least significant bits are used to find the address of word. Get it? So in memory interleaving, the main memory is built with multiple modules, and consecutive words in the memory are placed in the different modules. The goal of memory interleaving designing of memory is to broaden the effective memory bandwidth so that more memory words can be accessed per unit time. Are you getting me? So why we are dividing the memory into multiple modules, or why we are using memory interleaving technique? We are using memory interleaving technique to increase the bandwidth of the memory, so that we can increase the efficiency of memory, or we can decrease the waiting time of CPU. Are you getting? So main goal of memory interleaving is to design the main memory in a proper or effective manner, through which we can increase the memory bandwidth, so the waiting time of CPU will be decreased and the efficiency of memory will be increased, and also we can access multiple data or multiple words simultaneously at a time. Sorry. So main goal is what? By memory interleaving, we can divide the memory into number of different modules, through which we can access multiple words at a one time in our computer system. That's why we are using memory interleaving technique. Next, memory interleaving allow pipelining access of the parallel memory modules. It is a technique for increasing memory speed. Already I told you, it is a process that makes the system more efficient, faster and reliable. Already I told you these points. So an interleaved memory with n module is said to be n-way interleaved. Okay, what I told, this is right in theoretically. Memory modules or banks are connected to a system bus or a switching network, to which other resources such as processor or IO device are also connected. So look, this is the figure organization of 4-way memory interleaved. Similarly, we can organize the memory into n-way memory interleaved. Okay, so this is 4-way interleaved. So this is a system bus, and these are the module 1, module 2, module 3, module 4. Okay, and these modules are connected to the system bus by the help of a BU4, and the CPU are connected to the system bus. So in this manner, CPU and IO devices also access the memory modules by the help of system bus. Okay, this is the figure of, or this is the organization of 4-way memory interleaved. And there are two types of memory interleaving techniques. One is low order interleaving technique, another one is high order interleaving techniques. Get it? So what do you mean by memory interleaving technique? So memory interleaving technique is used to increase the throughput of memory by dividing the memory into different modules, through which we can access multiple data simultaneously at a time by the CPU. Okay, and we can divide the memory modules into two techniques. There are two techniques of memory interleaving. One is low order memory interleaving, another one is high order memory interleaving. So in low order memory interleaving, least significant bits are used as the address module, and the most significant bit are used address of words. Similarly, in high order memory interleaving, most significant bits are used as the address of module, and least significant bits are used as a address of words. So as for the example I told you, 0, suppose this is the 8 location, 0 0 So in low order memory bit, last two bits are used to as a module number. So 11 means module number, this one, and 01 is what? This is the address location of the word. So we are searching for which word? 8. So 8 will be in which location? 01 location. So 01 location. Similarly, in high order memory interleaving, so this is if 08, so 0 0 1 1 0 1 so 0 so first two bits are most significant bits are used to identify the module. So 01, so 01, this is the module, and last two bits are used to identify the word address. So 11 means this location, 11 is what? 8. Okay, so this is the memory interleaving technique. So memory interleaving is nothing but it is a technique which is used to spread the computer memory into different module in your computer system, and the main objective of memory interleaving is what? To increase the speed, reliability, execution of a memory, and also we can access multiple words from memory simultaneously at a time, and by this technique also we can achieve the structural pipelining methods also. So this is nothing but this is all about your memory interleaving.
and in next video we'll discuss about the different type of memory interleavings in details. That is what your low order memory interleaving, high order memory interleavings.